If you are planning to take calculus, this is going to be a series of videos where we will review everything that comes before calculus. With these videos, you can somehow review some of the materials that you need for calculus classes. First, we start with numbers and do some numerical operations. Simplify this expression. At the point of taking calculus classes, you should be able to optimize your numerical computations. For example, in this problem, you should not multiply these four numbers, or you should not be adding these four fractions. Before multiplying these four numbers and adding these fractions, I'm going to open the parentheses. So distribute these four numbers to the first fraction. Then my expression would be like 2 multiplied by 3. Now you can see, instead of multiplying, we can simplify first. So these two and these two, 3 and 3, 5 and 5, and 7 and 7 cancel out. So at the end, you are left with the product of these three numbers, plus 70, plus 42, plus the product of these three. So this is going to be, you can still add these four fractions and multiply with this, because when you add for these four fractions, you'll get the common denominator of product of these four numbers. Then these will cancel out, you'll have this product. The main idea is you need to know how to simplify or optimize your operations. If you don't optimize your numerical calculations, you will lose a lot of time. Let's do the following operations. This is another problem where you don't need to do the common denominators and subtract all these fractions from 3. The first thing I'm going to do is look for some kind of patterns. So the pattern in this problem is going to be all these numbers. This is 1 times 2, and you can see that this is 2 times 3. Now we recall one very important idea from maybe middle school algebra 2. So when you have a fraction like this, 1 over k multiplied by k plus 1, this fraction can be decomposed into two fractions with 1 over k minus 1 over k plus 1. If you do the common denominators here, you'll get 1 over k times k plus 1. Let's say if I put negative sign in front of here, this becomes negative, this one becomes positive. I can rewrite all my fractions using these formulas. Minus 1 over 2, using this formula, it means that I have minus 1 over 1 plus 1 over 2. Minus 1 over 6, it's minus 1 over 2 times 3. 2 times 3, it means I have minus 1 over 2 plus 1 over 3. The next one is minus 1 over 3 times 4. It means I have minus 1 over 3 plus 1 over 4, and so on. Now it's much easier to simplify this expression. These two together becomes 0. This is 0. This is also 0. In the end, we are left with, so that's equal to 3 minus 1. And these are all gone, so we don't have these anymore. Minus 1 over 8, or 2 minus 1 over 8. So this is a very simple fraction, 15 over 8. So that would be the result of this expression. Problem number 3. So as I said, so this is going to be your general approach for all of the problems from now on. So instead of multiplying, try to do division first and factorization first. So that will make calculations faster. So for example, instead of multiplying 2008 with this 8-digit number, I'm going to do something like this: 2008 multiplied by, this number is divisible by 2009, because 2009 and 2009. So let me pull up my calculator. 2009, if I divide that number by 2009, I'll get 10,001. Instead of this number, I'm going to write it as 2009 multiplied by 10,001 minus 2009 multiplied by, I will do the same thing for this number. It's 2008 multiplied by 10,001. After rewriting the expression like this, what we see is that this number is exactly equal to this one, because it's a product of 2008, 9, and 10,001. Same three numbers here. So the difference is going to be just 0. If you do a little bit smart approach to this problem, you don't need to do the multiplication. It's just factorization and the result turns out to be 0. Okay, this one is a little bit tricky. I'm just going to show you the solution and you'll try to get the idea, okay? So I'm going to replace some of the numbers with letters. So we have 3, 6, and 4. Since 6 is 2 times 3, I'm going to rewrite 4 as 2. So that's going to be, instead of 4, I will write 2 squared to the power 9 plus 6 to the power 10 plus 3, 20. Now I can rewrite it as 2 to the power 18 plus 6 to the power 10 plus 3 to the power 20. Now I'm going to replace some of the numbers with letters. Let's say 2 to the power 9 because the half is A. 3 to the power 10 is B. So in that case, if I replace it like this, 2 to the power 9 is A, this is A squared, plus 3 to the power 10, that's B, 3 to the power 20, that's B squared. What about 610? So if I multiply these numbers, so 2, 9 multiplied by 3, 10. So if I multiply 1 more 2, that becomes 210 and 310, right? Which is 610. So that's, and this part is 2AB. 2AB. Now in terms of A and B, this expression turns out to be A squared plus 2AB plus B squared, which was A plus B squared. So this number is a square of some number, or if we want to be exact, square of this number, and it's not prime because the square of a number is not a prime number. So this number turns out to be composite number, which is the perfect square. And this is the last problem with the numbers. Here we are going to pair numbers by 2. Let's just compute each pair and see the result of each pair instead of doing all the numbers at the same time. So the 1 minus 2 is -1. 3 minus 4 is -1, and so on. You just keep going. So these triple dots, you just keep going up to 100 with alternating signs. 99 minus 100 is -1. So since there are 100 numbers, we will have 50 pairs. So each of the pair resulting in -1. So the result of this expression is -50. So summarizing the idea with the numbers is that if you want to save some time, you need to optimize how you calculate some numerical expressions. With faster numerical calculations, you can spend more time on calculus concepts.